Hello everyone. So this is the problem of the day today, rotate list. We are given the head of a linked list and we have to rotate the list to the right by k places. So this is the example 1, 2, 3, 4, 5, and k is actually equal to 2 here. So after one rotation, this is going to come here, right? So 5, 1, 2, 3, 4, and the second rotation, this is going to come here. So 4, 5, 1, 2, 3, right? This would be the answer. Now we can say that when we are rotating the list to the right by k places, the last k nodes are actually coming to the front, right? The last k nodes, the last two nodes were 4, 5, and now they are in the answer coming in the front, right? The rest of the list has remained the same. Or we can say that the first n minus k nodes are actually now to the right, right? So n is actually the length of this list, right? This is n and k is this. So the first n minus k elements are now to the last. So we can say that the first n minus k elements will become the last elements, and the new tail will be actually n minus kth element, and the new head will actually be the next element to the n minus kth element, right? And now this particular thing would be tail, so it would be pointing to null, right? It's pointing to null. Okay. So now let's quickly look at an example to better understand the problem. Let's look at this example. So if we are given 0, 1, 2, now I can see different rotations on this particular linked list. And we are given k is equal to 4. So for 0, 1, 2, the first rotation it will become 2, 0, 1. For second rotation it's going to become 1, 2, 0. For third rotation it's going to become 0, 1, 2 again. So we can see that after every nth rotations it's going to become the same thing, right? So for k is equal to 4, obviously we are going to get the same rotation like we did in 4 modulo 3, right? We can say the first rotation is actually similar to the fourth rotation. The fourth rotation is similar to seventh rotation, and so on. Because after every n rotations, I'm going to get the same value, right? So when k is equal to 4, I can say that 4 modulo 3 rotations are going to take place, right? Because it's one and the same thing. It's going to give me the same result. So let's just take a quick look at this example to understand the implementation part. Here we are given 6 linked list where k is equal to 2. So what we are going to do is, for my first n minus 2 elements are going to be put to the last, right? So my answer would be something like 5, 6, 1, 2, 3, 4, right? So first of all I'll have to calculate the length. So I'll say my node, I'll initialize my node to the head and will traverse till my node's next is not equal to null, and I'll calculate my n to be 6. Then I will have my head as well as tail. When I'll be traversing my list, calculating the value of n, I'll also note my tail. Okay, so I have my head and my tail. So I have my head and tail here, and also I know now that n is equal to 6. What is to be done next is that I have to take this linked list and put it here, right? So these would be my n minus k elements, that is 6 minus 2 elements, that is 4 elements. So I will traverse again within this linked list, and I'll come here in this node and do what? For this linked list, the new head is going to become this particular node's next. So now for putting this linked list here, we need to do tails next is equal to head, such that after 6 we have 1, and so on. So we'll also do tail next is equal to head. And in the end, we know that 4 is now going to become the new tail. So 4's next would now be actually pointing to null. So nodes next would actually be equal to null now. And then we are going to have this new list where my head is actually node's next value and my tail is actually the node's value, and my previous head has now become last tail's next. Let's quickly implement the solution. So we know for sure that if I have a linked list with no length, or I have a linked list with one length, or k is actually equal to 0, so we are not making any rotations, then we'll simply return the head because we do not need to do any type of rotation in this, but in these cases, right? Then I'll calculate the length of the linked list, and for that I'll have to initialize a node who would be first of all pointing to the head of the linked list. And while my node's next value is actually not equal to null, I'll increment my length, right? And I also do node equal node next. So now I have length, right? Now what I need to do is I'll have to like store the tail. I'll have to store the tail of the linked list. So I'll create a new node tail, which will actually be equal to node, and I'll reinitialize node to be the head so that I can reach iterate so that I can iterate the linked list and reach the n minus kth node, right? So so I'll simply say node is equal to head now, and now I'll traverse till n minus kth index, right? So also we notice that k is actually going to give me, the rotation of k or k modulo n is going to give me the same results, right? So I'll simply do k is equal to k modulo n, and my rotations would be n minus k, right? So while my rotations is greater than 1, I'll simply do node equals node next and rotations minus minus. Also, I'll have to make sure that node is never equal to null. Also, before doing k is equal to k modulo n, for example, if I have n to be 4 and is 16, so obviously I do not need to do any rotations, right? So I'll simply check that if my k is actually coming out to be 0 only, then no rotations are necessary and I can simply return head. After I'm done traversing my linked list, and I'll get n minus kth node in node, right? So my new head will be actually the element which is next to n minus kth element, right? So my new head will be node's next value. Now my tail's next, I had stored tail here, right? My tail's next would be equal to the previous head value, and my node's next would actually be equal to null, and I'll simply return my new head. So let's check the solution. Compile error. Okay, I forgot one equals sign. Okay, it's accepting. Let's try to submit it. and yeah, it got submitted. So the time complexity would be bigger of n, and the space complexity would be bigger of 1. Thank you.